Good day everyone. Today we will be discussing frequency measuring instruments, tools used to determine vibration or rotational speed of mechanical systems. Understanding these instruments is crucial in diagnosing mechanical faults and ensuring stability in various engineering applications. I am Dr. Sendamari Kannan, Associate Professor in the Department of Mechanical Engineering at SVC. Feel free to reach out if you have any questions regarding this topic or any other material we cover in this course ME22088 Vibration and Noise Control. Let's begin with the first instrument, single read instrument or the Fullerton tachometer. Imagine a thin strip of metal with a mass at the end. This is essentially the single read instrument. The free length of this strip can be adjusted using a screw mechanism. Because of that, the natural frequency of this strip will change. When pressed against this entire setup on a vibrating body, so this will be the vibrating body. The screw mechanism is altered until the reed vibrates its maximum amplitude. It means at this precise moment, the excitation frequency equals the natural frequency of the reel, allowing us to determine frequency of the vibrating body directly. This instrument is particularly useful in environments where precise and direct reading of vibration frequency are necessary. And very important thing, the strips are marked with frequencies corresponding to the length. Usage, it is well known. We have to clamp end pressed against the vibrating body. The screw is adjusted until maximum vibration amplitude observed. Screw mechanism is very much important here. To adjust the free length such a way we are altering its natural frequency. Now let's move on to the multi-read instrument commonly known as Fram tachometer. Instead of a single adjustable reed, this instrument features multiple cantilevered reeds, each with a different natural frequency. When placed on a vibrating surface, so this will be our vibrating surface, the reed with the frequency closest with the natural frequency, that is the unknown vibration, starts oscillating with maximum amplitude. Since the reeds are pre-marked with their frequency, identifying the vibrating reed allows us to determine the frequency of the vibrating body itself. This method covers wide frequency range due to multiple reeds than the single reed instrument, making it ideal for broader vibration analysis. So what is the usage? The instrument will be used to measure largest amplitude as the frequency closest to the body's unknown frequency. Okay, key principle involved in this, the vibrating body frequency is determined by the known frequency of the most active reeds. Our final instrument is stroboscope. Operates on an entirely different principle. Instead of physical contact with the vibrating object, it emits intermittent pulses of light. When aimed at a rotating or vibrating object, the object appears stationary if the pulse frequency matches its movement. This allows for non-contact measurement, making the stroboscope highly effective in environments where physical interaction with the machinery is difficult or unsafe. However, due to human vision limitation, the lowest measurable frequency is around 50 Hz only. It is concluding that this stroboscope appears stationary when light pulse frequency matches its movement. We are going to change the light pulse of the stroboscope in this box. That is, this is the controlling box. Here we can change the frequency of this stroboscope light pulse. It may be lower, higher, precise, everything we can change it. So we can produce intermittent light pulse by adjusting the frequencies. The key advantage is non-contact measurements. We are not going to touch any machines, just away from the machineries and structures, which is a rotating one especially, then only we can able to measure the frequency. But since it is depending upon the person who is visualizing it, because we have to see by our naked eye that the object should to be appear stationary when the light pulse emit. So it depends upon fully on the operator. So he have to see whether the object is appear stationary or not. So it depends upon the human vision capacity. So the human vision capacity is, it is less than 15 hertz only. So the stroboscope also used to measure only up to 15 hertz. Restricted depend because it is depends upon human visions. Each of these instruments serves a unique role in frequency measurements, from direct contact methods like single read and multiple read instruments to optical techniques like stroboscope. Engineers use these tools in various applications, from machinery diagnostics to research in vibration control also. Understanding how these instruments work enhances our ability to analyze and maintain mechanical systems effectively. If you have any further questions or clarification, please feel free to ask. Thank you for your attention of this lecture video.